So today we're going to be talking about periodic trends, and if you're unsure of what periodic trends are, they are specific patterns that are present in the periodic table that illustrate different aspects of a certain element. These can include its size and electronic properties. Major periodic trends include electronegativity, ionization energy, electron affinity, atomic radius, melting point, and metallic character. These periodic trends arising from the arrangement of the periodic table provide chemists with an invaluable tool to predict an element's properties. And here we have so we can display this. You can choose a property to display here. So if we look at the boiling point, we could see which ones are similar based on the color scheme. And you have ones like helium that have very low, and ones like zirconium very high. This in kelvins. And you can just go through here, your discovery. You can see some are ancient, some are a lot more recent. You have 19th century here, a couple of 20th century down here, and it's a very interactive periodic table. And one of the major trends that I addressed earlier was electronegativity. And electronegativity measures an atom's tendency to attract and form bonds with electrons. And this property exists due to the electronic configuration of atoms. Atoms follow the Ostet rule, having the valence or outer shell comprised of 8 electrons. And because elements on the left side of the periodic table have less than a half full valence shell, the energy required to gain electrons is significantly higher compared to the energy required to lose electrons. So as you can see here, as electron negativity increases from left to right and down to up. And then moving on, we have ionization energy trends. And ionization energy is the energy required to remove an electron from a neutral atom in its gaseous phase. Conceptually, ionization energy is the opposite of electronegativity. The lower the energy is, the more readily the atom becomes a cation. Therefore, the higher the energy is, the more unlikely it is the atom becomes a cation. So here we could see ionization energy as it varies from atomic numbers. And similar to that first chart we looked at, you can see that the increasing ionization energy flows from left to right and down to up, similar to how it used to flow for the electronegativity periodic table. And these are some chemical equations right here that describe the first and second ionization energy. So the first ionization energy, we have this equation. The second one, we have this one right below it. And these can be used by chemists and students and scientists in general just to calculate the first and second ionization energies, which can be helpful. And there are a couple more trends I would like to go over. We have electron affinity trends, and this is the ability of an atom to accept an electron. And as you see, it's a very common trend of flowing from left to right and down to up. And just like that's what I said here, decreases from top to bottom. Last one I'll go over is atomic radius. And atomic radius is 1/2 the distance to the nuclei of the two atoms, just like the radius is half the diameter of a circle. However, this idea is complicated by the fact that not all atoms are normally bound together in the same way. And this is actually very interesting because it's the opposite, because atomic radius flows different than electronegativity and ionization energy, because we see that it increases from right to left and from up to down compared to the other way where we'd go from left to right, down to up. So that is very unique. And that is very unique compared to the other periodic trends that we went over today. So thank you.